Okay, so in this problem, we are given an integer number n and we have to find the closest prime to this number n, and then we have to return the difference from that closest prime with this number n. Oh, so let's say uh, I have these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if n is given as 1, if n is given as 1, then we can say that the closest prime to 1 is 2. So if n is 1, then answer will be 2 minus 1, that is 1. If n is 2, then n itself is a prime, so I can simply return 0, difference from it. Answer will be 0. If n is prime, then I'll simply return 2 minus 2, because the closest prime is itself, so answer will be 0. So I can filter out the whole question with one condition, that if n, I can check for prime is prime. I can define a different function is prime. Now how that function is working, we will discuss it later. But let's say there is a function which returns true if I plug in the number that is prime in it. So it's check for n, if is a prime, then it will return true, and in that case I will return 0 as my answer. Else I will to check that which is the closest prime to that number. Okay. So now for if n is 3, then we know that which is the closest prime. I have option 2 and 5, but 5 is 2 unit ahead of 3 and 2 is 2 unit behind the 3. So answer will be 1. Minimum distance is with 2. The answer will be 1 here. So what I'll do, for any given number n, I'll traverse from n till 1, and I also traverse from n till 2n. I'll traverse right to left from n to 1, and I traverse from n to 2n, and I check what is the prime number. If while moving from right to left, if I spot a prime number, then I'll consider as the nearest prime in left. And while traversing in right direction, if I spot the first prime number, then I'll update that value in nearest prime in right. So what is NPL? It is nearest prime in left. And what is NPR? It is nearest prime in right. So for this, what can I do? I run 2 for loops. So if first for loop will be for int I equals to n minus 1. Since I have to traverse in left, I'll go from I minus 1 to I equals to 1. Okay. So in this, while traversing in left side, if I spot the first number, I traverse and I check every number if it is a prime or not, and I run this prime function on I. If it is a prime, what I'll do, I update my NPL with this I, and I break out of that loop, because I no longer need to check for next number as a prime. So my job will get done whenever I find a prime number. Similarly, I traverse from I equal to n plus 1 till I equals to 2 times n. Okay, and whenever I spot a prime number, what I'll do, I will update my NPR with that. Sorry, here it is, I. So I'll update that NPR with I and I'll break out of the loop. So by the end of these two for loop, I will have NPL that is having the value closest prime in left, and I will have NPR that is the closest prime in right. Let's say it is X and let's say it is Y. So what I have to return? I have to return minimum of what? My number is n. I'll take its difference with NPL. I'll take its difference with NPR. So whatever is the minimum, I have to return that. So I'll subtract NPL from n, and I'll subtract NPR n from NPR. So if this is minimum, then that will be answer. Otherwise, this will be my answer. Now we have missed one condition here, that what if there is no NPL? What if there is no NPR? If I traverse in left and I'll get no prime number, and if I traverse now either side, one of the side will contain a prime number definitely, but if the number is, let's say, 1 and B in left of 1 there is no number to check, so in that case what I'll do with NPL? So to counter that, I'll start with value of NPL as 0, and I'll start with value of NPR as 0. Initially I initialize both these two variables with 0. So before returning this directly, I will check whether I have found my NPL value or NPR value, whether there is a prime number in left or not. So for that I will check if NPL is not equal to 0 and also NPR is not equal to 0. In that case I can return minimum of n minus NPL and NPR minus n. But what if NPL is 0? What if NPL is 0? In that case, definitely there will be a prime in right side. In that case, I'll return NPR minus n only. And the last case is if there is no prime in right but there is a prime in left. So else I'll return n minus NPL. Cool. So we understood how to find the how to spot the closest prime, but how is this is prime function internally working? How to check whether the number is prime? So the next part of this problem is checking whether a number is prime or not. Okay, so now we will understand how to check if a number is a prime or not. So first of all, observe this fact that we can represent any number as a product of some two numbers, right? Let's say if I have a number 8, I can represent it as a 2 times 4, right? If I have a uh, 10, I can represent it as 2 times 5. If I have a number, let's say 15, I can represent it as 3 times 5. If I have a number 16, then I can represent it as 4 times 4, or I can also represent it as 8 times 2. So there is at least one pair for every number n. For every number n, for every number n, I can say that there is a pair x comma y. There is a pair x comma y such that x times y is equal to n. There is at least one pair for every number. I can find at least one pair of x comma y. When I multiply those two numbers, that becomes equal to my n. Even in case of prime number, let's say I have 7 is a prime number, so I can represent it as 1 times 7. Right? Even in case of prime numbers, I can represent it as 1 times 7. If it is a prime number 13, I can represent it as 1 times 13. So for all numbers, I can represent them as a product of some two number. There is at least one pair I'll get. In case of prime numbers, it is a one pair only. Okay. Now, in all pairs, we know that either both of the number will become equal or one of the number will be less than other, right? That is obvious, because if I have two number x comma y, what are the possibilities? First possibility is that x is equal to y. Other possibility is that either x is less than y or y is less than x. Okay. These are three possibilities for any two number. Either they are both are equal, or x is smaller number, or y is smaller number. Okay. Now let us assume that the smaller number is x. Okay. Now smaller number can be anyone, but I am assuming that x is my smaller number. Right. Here I am assuming that x is that smaller number is x. For that, what can I say? That x is less than y. But in the case of equality, it can become equal to y as well, right? So what can I say? That maximum value of x will be y, right? So from this inequality, I can say that maximum value of x is y, right? So x become equal to y or x become less than y. So x is that smaller number from the pair that is a product of a number, right? So if I consider the maximum value of x, if I consider the case of equality when x become equal to y, then I can say that y times y become equal to n, because our equation was x times y equal to n. So I plugged in y here in place of x. So what I got? I got y equal to root n. So from the equation 1, I can say that maximum value of x is root n. Maximum value of x is root n. And since x is less than y, so I can say that x have range from less than root n. And since x is a positive number, so it can have only positive value. So in that case, I can say that x is ranging from 1 to root n, right? So I figured out that any number n can be represented as a product of two number x and y, and I assume that x is that smaller number. So for that smaller number, I derived this condition that x is ranging from 1 to root n. X, the smaller number, cannot go beyond root n, right? So for any number n, there must be at least one pair xy such that x times 1 is equal to n. And if I assume that x is my lesser number, then automatically y will be a bigger number, and x in the range 1 to root n. So how this will look like in case of prime number? In case of prime number, there is only one lesser number, and that is 1. For example, if I have a number 7, And if I represent it as a product of two number, then there is only one possibility, 1 times 7, and there is a lesser number is 1. In case of 11, the lesser number is 1. 5, 1 times 5, because prime numbers are only divisible by 1. So I can say that in their product, lesser number is 1. So what I have to do, instead of traversing from 1 to n and checking whether number is divisible by whether number n is divisible by that number, any number from 1 to n, I'll check from 2 to root n. So I traverse from 2 to n, and if none of the number from 2 to n is a factor of n, none of the number from 2 to n is dividing my n, then I can say that in that case the only number which is dividing my n is 1, and in those cases lesser number will be n. So else case will be the lesser number is 1, and in that case n will be a prime, n will be a composite number, n is not, the I is a factor of n, the number is a prime. So else, in the else case, when if I got a number from 2 to root n, if there is a number that is dividing n, then in that case I can say that lesser number is greater than 1, other than 1. In that case my n will not be a prime. So if I write a pseudocode, I can write it as for I equal to 2. I'm not checking for 1 because I know that 1 can divide any number. So I'll go from 1 to square root of n. So instead of writing square root of n, I can write I times n is less than equal to n. That is same as writing I is less than equal to root n and I plus plus. So if my number n is divisible by I, in that case I'll simply say that it is not a prime number, and I'll return false. Even after traversing from 2 to root n, I don't get any such I for that is dividing my n, in that case that number will be a prime number, and I'll simply return true. And I have to handle the case of when n is equal to 1. So for n equal to 1, if n is equal to 1, I don't go in this loop and simply return false. Okay, we don't have to check this for loop for n equal to 1. I have to deal n equal to 1 explicitly. For the rest of the numbers, I can check what is my lesser number that is dividing n. So this is it.